Hey, how are you? By the end of this video, you should be able to write the equation of a circle when the radius needs to be found using Pythagorean theorem. So this is part 2 of our circle equation series. So let's get to work. Here's a warm-up. I want you to find the distance of AB. So essentially, you have two ways to find the distance. And let me give you those two ways. You could use Pythagorean theorem or the distance formula. So I'm going to go ahead and just use Pythagorean theorem. So here's what you need to do. You need to form a right triangle using the given points. So here's how you form the right triangle. First, you're going to connect A and B. Now, think of AB as the hypotenuse of a right triangle. So I'm going to form a line here, and I'm going to form a line here. Now you could see what I meant when I said think of AB as the hypotenuse. And think of the dashed lines as the legs of the right triangle. So what's the measurement of the leg over here? It's 2. What's the measurement of the leg over here? Well, let's count the boxes. 1, 2, 3, 4. So we could use Pythagorean theorem now to find the missing side AB, which I'm going to call C. So use Pythagorean theorem. 2 squared plus 4 squared equals C squared. 2 squared is 4. 4 squared is 16. So we get 4 plus 16 equals C squared. 4 plus 16 is 20, so we get 20 equals C squared. Square root both sides. The distance is radical 20. So the distance of AB is equal to radical 20. Okay. What is the equation of the circle shown in the graph below? So if you recall from the last lesson, to write the equation of a circle, you need the center and you need the radius. Now, the center is right over here, and the center is -2, 1. Now, the radius is not so easy, and I'm going to explain to you why. Let me just zoom into that for a second. I think I might have zoomed in too much. Let me zoom out a little bit. Still too much. Okay, give me a second. I actually had to end up leaving it like this. I can't zoom in anymore because of my screen settings, but this is the point I was trying to make. If you try to count the radius like we did in the previous video, from here to here, you get approximately 1, 2, 3, and a little bit more. But we don't know exactly how much that distance is. So we don't have an exact radius. So what do we do then? What do we do to find the distance? Well, to find the radius, we need to form a line from the center to an exact point on the circle. What do I mean by exact point? Well, this is an example of an exact point. It's not a decimal. So I drew a radius there, And what I'm going to do now is form a right triangle like I did for the warm-up. And I can use Pythagorean theorem to find the radius. So I know that this length here is 3, and this length here is 2. So I'm going to use Pythagorean theorem to find the radius. So it's going to be 2 squared plus 3 squared equals r squared. So 2 squared is 4, 3 squared is 9. So 4 plus 9 is equal to r squared. 4 plus 9 is 13, so I get 13 equals r squared. Square root both sides. So the square root of 13 is equal to the radius. So the radius equals the square root of 13. We're going to leave it like that in radical form. So let's get the equation of the circle. So the standard equation of a circle is x minus h squared plus y minus k squared equals r squared. So we substitute for h and for k, and we're going to also substitute for r. R is radical 13. Let me just move this a little bit this way, and let's write radical 13 in there. So radical 13. Okay, so now we simplify the sign. So x minus negative 2, that's x plus 2. That's going to stay as y minus 1. Radical 13 squared. Well, let me remind you of something. Whenever you square a square root, you lose the square root. So let's go back. Radical 13 squared, so we're squaring the square root of 13. We're going to lose the square root, so we're just going to get 13 for the r squared. So this is our final answer. This is the equation of the circle. X plus 2 squared plus y minus 1 squared equals 13. Okay, I hope this video helps. Have a great day.